Okay, ladies and gentlemen, we are going to write a TI-83 or TI-84 program to help us simplify angles like 9 pi over 8 and to determine and generate reference angles and working angles in the second and fourth quadrant. Okay? So in order to do that, we're going to need to come up with some variables. So we can, instead of 9 over 8, we can use a variable like a and treat this fraction like a pi over b, where both a and b are integers. And in our program, we're going to just deal with this fraction a over b. We're not going to type in pi, and that way the calculator can help us keep these fractions in lowest terms. So the a over b in this case would just be 9 over 8. Are you ready to start? Let's go. In order to make a new program on your TI-83 or 84 calculator, you hit the program key, go over to new, and then you're going to hit enter, and the alpha lock is already on. You see that? So we're going to type the name of the angle, and right now I just want you to call it ANG, which is short for angle. Hit enter, and you have a nice blank program. All right, the first thing we need to do in our program is input the values for A and for B. To do that, you're going to hit the program key, go to IO for input output, prompt, enter, and we're going to enter alpha A, comma, alpha B. That's how you prompt for the user to input the values for A and for B. Here we go, hit enter, we're ready for our next line. What we need to do now is we need to have some value in the calculator. We're going to call that T, which is going to represent like the decimal value of a over b, so we can manipulate that and add it and subtract it and do some things with it. So in your program, to do that, we do alpha a, and we're going to divide that by alpha b and store that into alpha t. All right, and of course at any time you can pause and go rewind, take a look at some things. Now, first thing we're going to do is we're going to find a coterminal angle. Okay, coterminal. Remember, coterminal is taking t and adding 2 pi or subtracting 2 pi till we get to a terminal side on the unit circle that is within 1 revolution of 0. So within one revolution, we need to keep adding or subtracting 2 from our fraction. Right? Not 2 pi because we're not using pi. So add or subtract 2. So watch this. In our program, we are going to write a little loop to do that, and we're going to do that in program, while, and then we're going to do it while alpha t is second test less than 2, enter. While it is that, we're actually going to add 2 to t. So if t happens to be less than 2, we need to add 2. So that's going to be alpha t plus 2 and store that back into t. And then I'm going to go to program 7 for end. And what I'm going to have you do is do the same while loop for t greater than 2. Okay, hopefully you wrote that second while loop. While t is greater than 2, t minus 2 stored into t, followed by an end, and we're ready to go on. We can now display the coterminal angle and what quadrant it's in. So watch this. You're going to go to Program, IO for input output, display, and we're going to display alpha quotes, and then now you can hit the alpha lock, second alpha. See how this is an alpha lock? And you're going to type out the word coterm angle, and it'll look like this. C-O-T-E-R-M, space is over the 0 key, A-N-G for angle. We're going to finish our quotes, hit alpha to remove the alpha lock, and then we're going to need to type comma, and then we're going to display t math as a fraction. That will give us, and then I'm also going to display quotes, let's see, alpha quotes times second pi here. The reason we're going to do that is to remind us on the screen that this fraction that would come up, like a 9 over 8, means that it's 9 over 8 times pi. And then here's how we're going to display what quadrants it's in. So you'll go to Program, I/O, Display, and then you're going to do the same thing. Second alpha lock and type quadrant. Now, after you've typed display quadrant, I actually need to put a line after you do display quadrant. What you're going to do is we need to write a statement here that is going to determine which quadrant our coterminal angle is in. 1, 2, 3, or 4. So in order to do that, what we're going to do is we're going to write something that looks just like this. It's going to be in the math num I part for the integer part of the number. When we take t, multiply it by 2, we're going to add 1. We're going to take that and store that into a variable q. And then all we have to do is program I/O display q. All right. So what I'm going to actually have you do is actually run this program now. So watch this when we do the running. We're going to go to second quit. All your work is automatically saved in the RAM of the calculator. In order to run your program, you're going to type program. Leave it on EXEC for execute. Find the ANG program, hit enter. This comes to the home screen, hit enter again, and we have no errors. Good thing. I'm going to type in 9 over 8, and we see the coterminal angle is 9 pi over 8, and it's in quadrant 3. If you want to run it again, what if we put in something like 19 pi over 4? It gives you the coterminal angle of 3 pi over 4 in quadrant 2. And we're almost ready to finish writing our program. In order to get back into the program editor, you're going to type program, edit, go to the ANG program, and then you're back here in your code. We're going to go all the way down to the end, and we're going to write a little bit more code. So we need to find the reference angle. In order to do that, right, knowing the reference angle is always going to be in quadrant 1, it's going to be something based on pi. We need to get the distance, the rotational distance from wherever that angle is to the x-axis, where the x-axis here over this side here is pi, which in our fraction terms is just 1. 1 times pi, 1 over 1. So watch this, how this is going to work out. We're going to take the math, and we're going to go to number, ABS for absolute value, and we're going to take our value of t, subtract the math, the integer part again, and we're going to take our value of q, which is our quadrant value, divided by 2, close both parentheses, store that into a reference angle, alpha r as a variable. Okay? So all you need to do now is display the reference angle as well as the two working angles in the two quadrants. Okay? Okay. You have the absolute value. We just did that. This next part here, the line that said pause, you're going to find in the program, control, pause, that's 8. And then the rest of these lines you can actually type in yourself. Display the reference angle in quadrant 1 is just going to be r as a fraction. The working angle in quadrant 2 is 1 minus r as a fraction. And the working angle in quadrant 4 is the opposite of r, where r is your reference angle. So you can pause it here and type that in. You know how to type in, and you know how to get to all of these commands. And then the neat thing here is when you go to second quit, hopefully this still runs. We'll put in 9 and 8 again. Watch what happens now. The coterminal angle, still 9 pi over 8 in quadrant 3, but watch about the reference angle. The reference angle was pi over 8, first quadrant. The working angle of quadrant 2 was 7 pi over 8. And when we needed the inverse sign, we needed the one in quadrant 4, negative pi over 8. That's where the negative pi over 80 comes from, and you just created a program to generate that. All right, well, good luck with all of that, and enjoy.